Hello everyone, welcome to this session on Git Merge conflict. Today in this session, we will be going through how you guys can go ahead and solve merge conflicts in Git. Today we are also going to understand what Git Merge is basically, and I'm also going to give you a very quick refresher on what Git is, right? So let's go ahead and get started with Git, guys, by first looking at the agenda. So in a very brief manner, I'll introduce you to what Git is, what is the Git lifecycle, the common Git commands that you guys can use, and then I will be talking about merging in Git, right? So what exactly merging in Git is, how can we simulate a merge, and how can we simulate a merge conflict? In what cases merge conflict happens, that we will cover in this session. All right, so now let's go ahead and get started with the first topic, which is what is Git. So I guess you already guys know what Git is, but to just give you a brief idea, guys, Git is basically a version control system. And what that basically means is that for tracking changes in your code files, if you require a software, that software is Git, right? It will track each and every alphabet, each and every line, each and every word that you change in your code, and it can tell you the difference between two codes that you have saved at two different times, that what line changed and who exactly changed it as well, right? So Git is very popular when basically you want to do team collaboration, right? So if you want to check who changed what line in which code file, you can also check that using Git. Okay, now what is the Git lifecycle? So basically, there are three things in Git which are very important. The first one is the working directory. Then you have something called as the staging area, and then you do something which is called as commit. Now, working directory is the place where you basically work. So if I were to explain you from a diagram, you can imagine that, let's say this is the folder wherein your code exists, right? So what you do is first you initialize a Git repository. So there's a command for that, which is called git init. And once you initialize a Git repository, then what happens is in that folder of yours where the code is present, Git starts to track all your code files. All right. So once you are done with your code, what you do is you tell Git which files have to be saved in the Git file system, right? It will not automatically save all the files which are there in the folder, or it will automatically not track all the files which are there in the folder. It will only go with the files that you specify to Git, that these are the files that you want to track. And the simple reason for that is that whenever you're working with code, right, there could be a lot of files which your code is actually developing, right? It could be some output files, some log files, some files that you do not care about, right? So you can tell Git that, you know what, these 4 or 5 files or these 4 or 5 folders are the ones that I want to track in my code, and the others I actually don't want to track because they probably are output logs or they are something else, right? So now the way you tell Git that which files you should actually track is called staging, right? So you stage the files for Git which you actually want to track, right? That's what staging is. And once you've told Git which files to track, the next step is to actually save those files, which is basically called commit, right? So what you do is, in a brief manner, if I'll tell you, you first stage the files that you want to commit, and after that you commit those files, and then they get saved in the Git file system. And when I say they say get saved in the Git file system, they basically get tracked by Git as to what are the changes that you have done in the file with respect to the previous save or previous commit that you did on the Git file system. Now, this will be more clear when I actually go ahead and execute the commands, right? But once the file is committed to Git, what happens then, right? So all this stuff, all these things which just happened, right? Which basically was initializing the Git repository, then committing the files on your Git file system, then basically going ahead, and now it is ready to basically share it with your team. So right now everything is happening on your local system. Now if this has to be shared with your team, obviously it has to be at a central location which everybody can access, and that central location is nothing but GitHub, right? So GitHub is a place, it's basically a website where you can upload all your code, and this code can only be uploaded once it is committed on your local repository, right? So once you commit all the code that you want to upload on your local repository, then all you have to do is specify which GitHub repository you want to upload it on, which should be yours, and then it gets uploaded over there. And from now on, any code changes that you are going to do in this particular project is going to go on this repository. And even others in your team, whatever code they're working on for this project will also be saved on this particular GitHub repository itself. Okay, so this was a brief on what Git Lifecycle is. I'm pretty sure all of you already know that, but this was just a refresher for you. Now let's go ahead and understand some common Git commands, right? So again, a refresher as to some commands that you can use in Git, right? So first of all, there are 4 things that you can do with Git. You can either create a repository, you can do some changes, you can do parallel development with your team members, and then you can sync your GitHub along to your local repository. So these are the 4 things that you can do in Git, and we will be touching base on the commands with respect to these 4 things, which is creating repository, making changes, parallel development, and syncing repository. So let's start one by one. So let's start with creating repository. So the first thing that you do is any folder that you want to be tracked by Git, you basically do a Git init, which basically initializes the Git software in that particular folder. So by default, Git does not work on every folder on your system. It only works on specified folders that you tell Git to track, right? And what are the command to tell Git that this is the folder that you have to track? It is basically Git init. So what I'll do is, let me quickly open up a server, which we are basically going to track. So what I'll do is, I'll just launch a Linux server, and on that we'll be working with Git. So I'll just click on launch instances. Now guys, you don't have to do this. What you can do is you can install Git on your system, right? If you just do a simple Google search for install Git on Windows or install Git on any operating system, you will basically get a guide on how to do that, right? I'm not doing it on my local system because I don't have Git right now installed, and I don't want to waste time in that. So the good thing about using a server on any cloud instance like AWS is that Git is already installed on that. It comes pre-configured, right? So you can skip this step if you want. You can install Git on your system. So for example, if you're using Windows, all you have to do is search for install Git Windows on Windows, right? And the first link that you get, just click over there, and you can download the Windows setup from over here, right? When you have to do it on Linux, let's say if you're working with Ubuntu, all you have to do is type in the command sudo apt-get install Git. Just by passing this command, and Git will be installed. So right now I have my server which is running. So let me quickly connect to it. So I'll just open the terminal. And let me log into this server. Okay, so I'm logged in. So what I'll do is I'll create a folder called, let's say, demo_code. Okay, and on this, let's go inside this folder. And the first command that we have to pass in is initialize the Git repository, which is git init. Okay, so with this, I have initialized an empty Git repository in this particular folder, which is demo code. Okay, now any other folder on the system will not have Git tracking the files, but whatever files I will be putting in demo code now, they will be tracked. Okay, now I've passed in Git init. The next step that I do is I check Git status. Okay, so now that Git is basically installed in this particular, I have initialized Git in this particular folder. So now let's say I create 2 files. So let me create a 1.txt and let me create a 2.txt as well. Okay, so I have 2 files, 1.txt and 2.txt. So if I pass in Git status, it basically tells me, which files are tracked, which files are not tracked, in Git. So if I pass in Git status right now, you can see that there are no commits on this folder yet, right? There is one branch, main branch, which is the master branch, which is created. And right now, there are 2 files which are there in this folder, which are not tracked. Okay. Now, what happens if I pass in Git status in a folder which is not initialized? Let me show you that as well. So let me come out. Let me create one more folder called sample. And if I go inside this folder, let me pass in Git status. Can you see it says not a Git repository? Why? Because I have not initialized Git in this particular folder. If I pass in Git init and then Git status, it will show me the same output, right, for the sample folder. But I have not initialized Git, and hence it says not a Git repository. So I'll just come out, come back again into demo code folder. And again, if I do a Git status, you can see that it tells me the 2 files are there in this folder, but they are not tracked. That's what is the status of this particular folder for Git. Great. So that's what the Git status command does. Then if you have to stage some files, right, now you want to tell Git that these are the files that you should track. So how do you do that? By staging the files. And what is the command for staging files? Git add. So if I come back to my terminal, let's say I want to track 1.txt. So I'll just type in git add 1.txt. And that's about it. Now, if I do a Git status, you can see that it is now saying that there is a new file in the system which is 1.txt, which is yet to be committed. It is not yet saved, but it is staged. So 1.txt is there, and you can see it's in green color now. But it says untracked file. So still 2.txt is a file that Git is not tracking. You have not told Git to track it. You have told that, okay, 1.txt is a file that you are going to track. And how will it track it? It will track it by using the command git commit. Okay, so git commit is a command that now we are going to use to track the files. So what is the syntax for that? Git commit and -m, and then give a message. Message would basically specify what changes you have done in the 1.txt file. Okay, so for example, let's go ahead and type in git commit, and let's say this is created 1.txt. This message could be anything. This is basically used when some other developer is working in your repository and he wants to check the history of the code, who created the file, etc. Right? Hit enter, and now you can see the file has been saved. Okay, and if I do a git status now, you can check that there is one untracked file which is 2.txt. Git status says on branch master untracked files are 2.txt, nothing added to commit, but untracked files are present. Okay, which means 1.txt is not giving you any error now, which means it's saved in the Git file system, but it still tells you that 2.txt I'm still not tracking. Why? Because we did not stage it in the first place. Okay. Moving forward, one more thing that I can show you is that let's say I go ahead and I make some changes to 1.txt. Let me edit 1.txt file, and let me say Intellipaat is awesome. Let me type in that, save the file, and now let me do git status. So now you will see Git is tracking this file and will tell me that, you know what, 1.txt has been modified. But why is it showing you in red? Because Git, although you have modified the file, but you have not saved the file to Git right now. And that's why it's saying that 1.txt has been modified. And all you have to do now is, again, just stage this file and then commit it and give the message modified 1.txt. Okay. And now if again I do a git status, you can see that it only says that untracked files are 2.txt. It does not giving me any error for 1.txt. All right, great. So this is how you save a file. Then moving forward, if now let's say I want to upload my code to GitHub, how can I do that? So I will have to first add the URL for GitHub. Now how can I do that? The command is Git Remote Add Origin. All right, so if I quickly go to my browser, I can go to github.com and let's create a new repository here. and let's call it demo, and today is 29th, so 2910. Okay, this is a public repository that I'm creating. Let's create this repository. Now, once you create this repository, obviously you will get a link over here, right? Just copy this link, come back to your terminal, and now just type in Git Remote Add Origin and put the URL in quotes, hit enter, and now the origin has been added to your repository. Now all you have to do is push your changes to the GitHub, and in order to do that, the command is git push origin master. And what is it going to push? It is going to push the file that you have committed, which is 1.txt. So I'll just type in git push origin master. It will ask me the username, which is this, and the password. Let me type in that as well. It says authentication failed. Okay, could be, I think I have forgot the password for this. So what I'll do is, let me just sign out, and let me create, or let me log into some other repository of mine. Okay, just give me one moment, guys. I'll just get the code for my repository. Nevertheless, like I told you guys, all you have to do is just type in the username and the password, and then it should basically work out for you. Just give me one moment. I'm just pulling up the password. I think I wrote the password someplace, so let me get that. And from there we can basically go ahead and then log in. Okay, so I think I've got the password. So what I'll do is I'll just come back here again, do a git push origin master, and here you go. So once I pass git push origin master, now the code has got uploaded to my Git repository. Okay, now that the code is uploaded, I can just go to GitHub and I can just refresh and go to the repository, which was demo. So demo, I just created the demo repository. Yes, demo 2910, and you can see it says you committed the file 5 minutes ago, and now it has basically got the 1.txt file. It also shows you that you did 2 commits. So what were the 2 commits? You first created 1.txt and then you modified 1.txt. So what is this text that is visible over here? This is the message that you passed, right? So first message that we passed was created 1.txt, and then we pass the message modified 1.txt. Okay, so if you come back to the code, you can also see the fact that if you go inside 1.txt, it will also show you the text that you typed in, which is Intellipaat is awesome. Okay, so guys, this is how you can upload your code to GitHub by using the command git push origin master. Okay, then if you want to copy the code from any repository to your system, now let's say there is some friend of yours and that friend wants to copy the code on his system and then work on it. the command would be git clone and then the URL. And in case your friend has made some changes and you want to pull those changes in your system, the command will be git pull. Okay. If you want to create a new branch in Git, the command is git branch. So let me come back to my terminal and let me show you how that works. So right now, if you see, we just have the master branch on Git. The command is git branch. If you type in git branch, you will see the branches which are there in your Git file system. And this is created by default. Now, when you're working with merging always happens between branches, right? So merging basically means merging branches. So if I want to go ahead and create a branch, I can just type in git branch, and let's say this is feature 1. I type in that, and when I do a git branch now, you can see that I have 2 branches, master and feature 1. Okay. So if I want to delete a branch, all I have to type in is git branch -d, which basically means delete feature 1, and then the branch will be deleted. So now if I do a git branch, you can only see that master is there. Great. So what we'll do is we'll create a branch called feature 1, and this is what you were waiting for, right? So I've created a branch called feature 1, and if I want to go to this particular branch, what I have to do is git checkout feature 1. So I'm inside the feature 1 branch now. And now what I'll be doing is I will be doing an ls. So I can see in this branch, I have 1.txt and 2.txt. Now what I do is I add one more file. Let's say I add a 3.txt file, right? I edit this file. And let's say I type in hello world. This is the 3.txt. Now in 3.txt, since I've edited 3.txt, what I'll do is I'll just stage it. I'll commit it. I'll say added 3.txt. So now this file has been saved, right? But where has it been saved? It has been saved inside the feature 1 branch. So in feature 1 branch, as you can see, I have 3 files, 1.txt, 2.txt, and 3.txt. If I check out to the master, you will see I just have 1.txt file. Okay. So what happened? I committed 2.txt also in the feature 1 branch. And how did that happen? Because I typed in git add dot. What does dot mean? Dot means whatever is there in the directory, stage it and commit it. So once a file has been committed in a certain repository or in a certain branch, and if that particular file is not present in another branch, you cannot see it. Okay, so in the master, I can only see 1.txt. And what is the content on 1.txt? Intellipaat is awesome. If I come back to my master, my feature 1 branch, you can see, one second. Yes. So if I come in my feature 1 branch, you can see I have 3 files, 1.txt, 2.txt, and 3.txt. Right? So with this, you get an idea of what branches are used for. Branches are used for isolating different codes or different versions of codes. Okay. Coming back to the slides, what are merging branches? So merging branches basically means that whenever a code is complete in some other branch, and now you want to make it a part of the main code, what you do is, let's say feature 1 is my complete code. Whatever code I had to complete, I've completed in feature 1. And now what I want to do is I want to put this code on the master branch. I want to integrate it with the main code. So that the lingo or the language for that is merging feature 1 on master. Right? That is what merging means. That whatever code you have on the feature branch or whatever code you have on the second or third branch, if you want to make it a part of another branch, you basically merge the branch in the main branch. That's what merging is. Okay. So if I were to explain merging in a very simple manner, you can think of it like this, that once the developer has finished his code or feature on his branch, the code will have to be combined with the master branch, and this can be done in two ways. Now, when you want to merge, there are two ways of merging. One is called Git Merge, and the other is called Git Rebase. So we'll be understanding both of these. So Git Merge basically means that when you're done with the code and you want to basically commit it to the main branch, you do a Git Merge. Now, there are some properties between Git Merge and Git Rebase based on which it has been differentiated. When you do a Git Merge, whatever the history of the branch is, like whoever worked on that branch is basically saved in the Git repository as a log, right? So if I were to show you the log, if I do a Git log, you can see that I get all the commits which have happened on this repository. Right. So what happens is when you're using a Git merge, this log never changes. But when you're using a Git rebase, this log changes. Okay. Now, if you are a developer, just think about the fact that in what cases would you want the log to change, right? A log is basically maintained so that the other developers can see what is happening on the repository or how the things have happened on the repository. Right? But in some cases, log probably does not make sense because let's say only I am working on a particular branch and only I have done the changes. So I will know what changes I have done, and probably I do not want to see if I'm creating one feature, let's assume, and for creating that one feature, let's say I did 100 or 200 commits based on the time it took, and every day I wanted to save my code. So whenever I wanted to save my code, I basically did commits. Now, when my feature is ready, what I want to do is, I don't want everyone to see that I did 200 commits. I just want to show them that I did one commit where I made the feature, and now I want to basically merge it on the master. So in case I want to show only one commit and not 100 commits of mine for a particular feature, I will do a Git rebase so that it results in a cleaner history. Right? Why would you not want to show 100 commits? Because in that case, the log will get full. And probably the other people are not interested in understanding like how I made the code. They just want to see, okay, so this particular guy, he wanted to make the feature. He made the feature, he committed it, and then he merged it on the master. This is what they would want to understand. They would not want to understand how I created that feature. Right? So in that case, if you want to change your own history, you use a Git rebase. But let's say now I've just changed everything, or I want to make some changes on a public branch, right? Let's say on a public branch, let's say on a feature branch that I am working on, 2 or 3 other developers are also working, right? And these 2 or 3 other developers have done 10 or 20 commits, and I have also done some 10 commits. Now, when I'm merging it on the master, what I want to do is I want to convert these 30 commits into one commit. Is this correct or not? This is never correct. Why? Because see, you can take account of your own work, but you cannot take into account what others have done. At the same time, if a branch is visible to others as well, they probably are looking at the history in their own version. So if you do a Git rebase on a branch which others can also see, right? And if they one day, if they log in and they see that yesterday they were seeing a different kind of history, and today the history has altogether changed for a particular Git repository, it does not make sense, right? So if this is a little complicated for you, let me break it down to you more easy. You can just imagine that whenever you're doing a Git merge will always be done on public branches. That is branches that others can also see. Git rebase will only be done on branches which only you can see. That is private branches or local branches. Okay, just imagine it like this and everything will be sorted. So if you talk about the output of what Git merge and Git rebase is giving you, both are giving you the same output. That is, the code is being merged. The only difference is that Git merge does not change the history of the Git, and Git rebase does. This is the only difference. Okay, so when will you do Git merge? Whenever you're working on a public branch. When will you do Git rebase? When you're working on a branch which is local to you, which nobody else can see. Okay, So what is the syntax for Git merge? The syntax is Git merge. What is the syntax for Git rebase? The syntax is Git rebase. Okay. So if I were to show you Git merge in a diagrammatic format, you can imagine that, let's say this is the master branch. So this is on this blue commit, I created a branch called feature A, right? So now on feature A, some other developer worked and he created 2 commits. Okay, and this commit is basically the final commit where he said the feature A is complete. Meanwhile, on the master, somebody created some other feature and he merged it on the master with a gray commit. Okay, so let's say this is feature B and this is feature A. Okay, so on the master, from the blue code, it has now turned to gray, but this gray code is not present on feature A, and this green code is not present on master branch. So what you do, you basically do a Git merge, and when you do a Git merge, what happens is a new commit is done, and on this new commit, not only this gray code is present, but also this green code is present, right? So both the codes get integrated into this new commit, which is done by Git merge. I hope you understand. Let's say over here, I just have the home page, okay, in this blue commit. Now what happens is, over here, I create a branch called feature A, and I tell some developer, I've created the home page, you create the about us page, okay? And I gave some other developer some other work where he had to create the login page. So he created the login page and he put it on the master branch, right? But this guy does not have the login page. He just is creating the about us page and he just has the blue commit, because this is how the branch is going, right? So now when this guy will be putting his code on the master, it does not mean that this gray commit will go. All the code has to be integrated, right? So what happens is, this green commit, you want to merge it onto the master, so you merge it. So a new commit is created where not only this code is present, but also this code is also present, right? And that is what this blue commit means. And then what you can do is, if you want to further go ahead and enhance your feature A code, you can do that. And probably when this is done, you can again merge it to the master. Okay, so this is a diagrammatic representation of how Git basically works. Similarly, if you were to look at the command for Git merge, this is how it looks. So if I were to implement it on my terminal, you can imagine it like this, that right now, if I go to my master, I just have 1.txt. And now let's say I gave this code to my developer and I assigned that developer feature 1 branch, and he has created 2.txt and 3.txt as well. Now he wants to put these 2.txt and 3.txt on the master. So how will I do that? He will first go to the master branch, git checkout master, and then he will do git merge feature 1, hit enter, and this merging is now done. And now if you basically check out the master branch, so right now I'm on the master branch only. If I do a git branch, you can see I'm on the master branch, right? And if I do an ls now, so when I did an ls, when I checked out to the master and I did an ls, I could only see 1.txt, right? But now when I'm on the master, if I do an ls, I can see all the 3 files, which is 1.txt, 2.txt, and 3.txt. Why? Because the changes which were there in feature 1 have now been integrated with the master branch. This is what Git merge does for you. And if you want to check the log for this, you can check the log in a graphical format like this. So these flags that I'm adding, it makes it a little more easier to see. You can see that you first created 1.txt, then we modified 1.txt on the master. Then basically what we did was we went to feature 1, we added 3.txt, right? And then this is the merge which happened on the master branch. Okay, so this was the merge that we did. Moving forward, now let's talk about Git Rebase. So like I said, Git Rebase will only be done when you don't want to change the history, and it can only be done on the local branch. It will never be done on the master branch. Okay, so to give you a perspective, let's say you have a master branch and you have a test branch. So what you do is you first create a branch where you have the changes, and you will only merge it on a branch which is local in nature, right? And once the rebase is done on that branch, all the changes will be, it will be integrated, but the history will change, and that is something that you do not want. Okay, so I will not be touching upon rebase because it will go into a separate discussion. Now let's come down to the main part of our discussion today, which is basically merge conflicts. Now, what are merge conflicts? So let's take an example over here. Let's say we are on the master branch, and we give our work to 2 more developers for working on feature A and feature B branch, right? So what I do is I have the master branch, and I tell 2 developers to also work on the code for feature A and feature B branch. Now what happens? This is how my function.c, let's say this is the code on the master branch as of now, right? And I give the 2 developers feature A and feature B branch, and on that this code is also present, and now they will start modifying this code. Okay, so let's say the developer A completed his work. He modified this particular code, right? And when he modified it, he wants to put it back on the master branch, right? What does that mean? Let's say developer A added a function 2, right? This is how my code looked like. Only function 1 was there in my code. Okay, now what developer 2 did, what he did was he basically added a function 2, and he said this is my code. So after the developer A changes the code, he wants to basically merge it with the master. So what he does is he adds function 2, he commits it on feature A branch, and then he pushes this code on the master branch. Okay, everything sounds good. So if we were to simulate this, I just come back to my terminal. Let me create a new folder. So let's say we create a folder called example. And what this guy did was, so initially, let's say I'm the main developer, so I initialize a Git repository, and I create a file called function.c. Okay, and I write a code where I say that this is what the code is, and I type in this is the initial code. I say this is the code. I stage this code. I commit it, right? Commit is done. And now what I do is, now this code I have basically made it live. Everyone liked my application. So what I did was I hired 2 more people, and then I wanted to make my code even better. So I hired 2 people, developer 1 and developer 2, and I told them, you know what? I have my code in the master branch. And now what I'm going to do is I want you to add new features to this code. So I'm giving you 2 branches. This is the branch for developer 1, and this is the branch for developer 2. So developer 1, you go ahead and make your changes in the developer 1 branch, and once I feel they are fine, I will integrate it on the master. So the developer 1 goes to his branch like this, right? And then he sees the code. Okay, so this is how the code looks like. This is how the code look like. Okay, so this guy had made a main function. So what I do is I create my own function. Let's say function 2. I create this function. So, and I say that code added by developer 1. Okay, I add this code. I stage it. I commit it, added function 2. Okay, so now what I've done is on developer 1 branch, I have basically went ahead and I have edited functions.c to have the function to code. Okay, but if I check out the master, obviously on the master, if I check out the functions file, only initial code is present. However, on the developer1 branch, function 2 is also present. So now that I see that function 2 is there, so I as a main developer, I'm told by developer1 that the code is complete, you can check it, and if it looks good to you, you can integrate it on the master branch. So I check the code, okay, so this function looks good to me. So what I'll do is I'll do a git merge of developer1. Great. So I have done it, and now on my master branch, so if I do a git branch, I am on the master. So now if I check my functions.c, I can see that function 2 has been added successfully, which is great. So this is what has been told to us in the example as well, that developer A, he made the changes, he added function 2. Similarly, developer B, now the developer 2 also started working on his branch. So let's check out to his branch. So he is working on branch 2, developer 2, right? So right now his code, if you look at, it's still having the initial code only, it's not having any functions. So what he did is he adds function 3 in it. So let's add function 3. He adds function 3. Right? This is the code by developer 2. I save it. And now if you talk about on the master branch, so on master branch, function 2 is present. On feature B branch, that is the developer 2 branch, function 3 is present. Function 3 in the sense, function 3 is present on developer B branch, developer 2, who has made it, has added function 3. And on the main branch, you have function 2, which was created by the developer. Okay. Now what happens after this? So now if I try to merge, so if I try to merge this code on the master, that is code from developer 2 branch, if I start to try to merge it on the master, I will get an error. Why will I get an error? I will get an error because, so let me show you that first. So if I check out, so first let me save it on over here. So let me stage it, commit, code added by developer 2, right? And if I check out on the master now, and if I do a git merge of developer 2 branch, you can see it says merge conflict in functions.c. Why did that happen? It happened because the changes that the master branch has. So master branch has, the code of developer 1 as well, right? But this guy, the developer 2, he just has the code which was given to him by the main developer, and he has his changes. He does not have the changes of the developer 1. And when he is trying to merge his file on the master, what is happening is that his code is not getting merged because his file is not having the complete code of what already existed on the master branch, right? The code can only be integrated when there are new changes on this commit. But there are new changes on the master branch as well, and there are new changes in this branch as well. Okay, and that is why there comes a merge conflict, because now the Git does not know whether feature A or the developer 1 work also has to be kept and developer 2 work also has to be kept, because both of them worked on the same file. So when two people work on the same file and they try to commit it on the master or on any other branch for that matter, when they try to merge that same file, you get a merge conflict. Okay, and this merge conflict has to be now, it has to be resolved. So how can you resolve it? You can resolve it by going to your terminal. So you get a merge conflict like this. So just type in git merge tool, right? And then you will get a user interface like this. So this is how your code on the master branch looks like. This is how the initial code looked like. And this is how the code on the developer B branch looks like. And this is the main code that is going to look like when it is basically merged. So now what you have to do is you basically have to go ahead and integrate the changes by hand over here. So it basically tells you that this is the head of the code, which basically means this is where the initial code looks like. This is how the initial code looked like, right? So you are fine over here. You can remove the extra lines. So, and then it says that this is the function 2 which was added. This looks okay to me. You can see there's a curly braces missing over here, so I can add that like this. Then this is function 3. This looks good, but I will have to remove this line which has been added by Git. This looks good, and this is the final curly braces for my main function. So I have to resolve whatever the conflict Git is facing manually, right? And once I feel this code is now perfect, I go ahead and save it. And once I save it, it'll ask me whether the other files I want to save. I don't want to save the other files. So I just type in, I want to save these files, and the Git merge conflict has now been resolved. So if I do a Git status now, it will tell me that the functions.c file has been modified, right? But it is yet to be committed. So I'll have to commit it. I'll do that. So how does the functions.c file look like now? It has the main code, it has the function 2 function, and it has function 3 as well. And this is what we wanted. So we have resolved the merge conflict, and now we just have to save it. Git commit -m merging developer B code. Done. And there will be one file which will be created, which will be the original file. When I say what do you mean by the original file, it is basically giving you, in case you did any error while resolving the merge conflict, you should always have a code which you can go back to. So this is what the code looked like when you were trying to merge. So in case this code stops working after the merge, you can again go back to this code, the original code, resolve things over here. And if the code is working fine, you can go ahead and delete this code as well, right? So I can just go ahead and delete it, right? And if I do a git status now, you will see that the status will now be clean. It says on branch master, nothing to commit, working tree, clean. So this is how, guys, you go ahead and resolve merge conflicts. So now I guess you have an idea of when merge conflicts occur. They always occur when two developers work on the same file and they try to merge it on the master branch. How do you resolve merge conflicts? I have also shown you. So now it's all about practice. Go ahead and practice this out. And once you have practiced it out, I think it will look good. So you can just have a look at the UI, which I just explained you. This was the developer 1 branch changes. These were the developer 2 branch changes. And this is how the original master branch looked like. So this is what the UI tells you. And this is the change, the main file where you're making the changes. You make the changes over here, save it, and that's how merge conflict will be resolved for you. So the original file will be saved for you. So in case you want to go back, you can have a look at over there. So finally you commit the file, and after committing the file, your merge conflict has been resolved. So with this, guys, we come to an end to this session. I hope this session was useful to you, right? I would recommend you to go through this session again and practice along with what I'm doing. Only then you will be able to gauge, the concept that I was trying to explain you today. So if this session was useful to you, please go ahead and hit that like button if you haven't already, right? And please also subscribe to the Intellipaat channel, because we will be coming up with more such videos in the future, so that you always get a notification when we are coming up with the next video. So with that, guys, I hope you have guys learned something new. And with that, Have a great day ahead and goodbye.